Right, we're going to have a look at how we can move from 3D model mode, so in a Part Studio, to what's called Orthographic. So at the beginning of the first video, I kind of showed you our direction of travel, where we're going to end up. So we're going to end up with a A3 page with a series of drawings of this object with dimensions and details for construction on it, right? Okay, so there's my model. Remember how I created it? I created it in one Part Studio, but as I created the parts, I made new elements. So there are 3 parts in one Part Studio. What I'm trying to say is I haven't used an assembly, so I haven't had to do any mates or anything like that. So I can't do anything clever with this. I can just show you it fitting together. So here we go. Let's have a look, first of all, before we go into orthographic mode, how we can view this object. There's a few things I haven't shown you yet. So, you've got things like isometric view, where you can choose your isometric view if you want to. You've also got things like perspective view. I don't tend to use it in engineering because, I don't know, if you're trying to do a rendering, it might be useful, I guess. Renderings where you want to try and make something look realistic. You've got views down here. So I'm going to take perspective off a minute and put it back into orthogonal. And I'm going to bring up this one here, like shaded with edges. So I can take the edges off if I want to. Or I can, let me put that unshaded on. So unshaded, you can view the tangent edges if you want to, but it's my unshaded version. And then I can go to one that looks translucent. Translucent kind of gives you a ghosted view, so you can see stuff that's going on internally. And then what else have we got? So we've got tangent edges visible. View in high quality, or section view. Section view is pretty useful, actually. What you can do there is you can knock out part of the drawing so that you can see behind it, and all it is invisible, so it's still there, Okay, so next thing I'm going to do is I'm going to go back into the view that says shaded with edges, and I'm going to show you these 3 buttons on the bottom here. So one looks like a protractor, one looks like a weighing scale, and one looks like a ruler. I'm going to click on the protractor, which is called Show Analysis Tools. And here I've got things like curvature map, zebra stripes. So what zebra stripes does, it shows you that's not the curvature map. Okay, that just shows you the surface of it. So if you go on to curvature map, you can have a look at stuff that's going on, right? Curve surface analysis. So if I go on there, it shows me what's going on that fillet radius, if it's an even curve. So we're just having a look, at the shape and seeing how it fits together. But what I wanted to show you most of all was this one here, which is called interference detection. So with interference detection, I'm going to close off that. So what you're going to do is you're going to be able to click on a part, click on another part, and see whether there are any areas where those 2 parts are jamming against each other. So those 2 parts, not a problem, right? So let's have a look now. This part and this part. Okay, so look what I've got now. So I've got interference detection has fired up and told me that the hole that's inside the knurled bit is too small for this bit to go through. But if you think about it, it's exactly what we want, right? Because that's a tapping hole that goes through the knurled bit that we made on the lathe. So it's 5 mil, and the bar that's going into it is going to be M6. So that's quite correct. So there you are. That's just an interesting little aside. Right, let's go into orthographic mode then, shall we? So click on the plus and go to create drawing this time, right? So when you create drawing, you have to do a few things. Click on custom template, ISO, just out of interest. ANSI stands for the American National Standards Institute. ISO is the International Standards Institute. We're going to go to ISO. We choose the paper size, A3. And then we click on the button down here that says third angle projection. So third angle projection means our plan view is above our front elevation. Okay, and we draw what we see where we're looking from, essentially. Okay, so you can include or lose a border. I'll just leave it as it is. Click on the OK button and let it load you a page. Right, it'll have a pre-made border on there and a title block that you need to fill in. So to fill in the title, so it already gives you the name of the person who's drawn it, and it gives you the date that you've created it as well. But you can put a title in here. You can put your name a bit more clearly in here. You can put your tolerance that you're working to. It says do not scale drawings. You can override that if you want to. So if you want to have drawing done to a certain size, then you can, right? So what I've got here, let's have a look. So I've got some parts that I want to bring into my design, right? So I've got blade, hacksaw model, and screencast, right? Oh, hang on a minute, I want hacksaw model, don't I? Right, so in this one, Part Studios, I need to get in this one here, hacksaw model. Right, now my parent view, that's the view I'm going to start off with. I'm going to have from the side like this. And we get the picture that that object is going to just about fit on our page, right? Like that. Now, what happens? That's our parent view. So I'm on a selection here called projected view. So if I hover above it, I automatically get a plan created as my plan view. That's quite cool. So I've got front elevation and a plan. I'm going to label those views before I go any further. So click on the A button, drop a note on the page like this, and drag that out wider. This is called my front elevation. And this one is called my plan. Right, so this is what I would call a general arrangement drawing. Or a GA, all right? So that's my general arrangement drawing. And it's not usual to put dimensions on a general arrangement drawing. You can put reference points. So on this one, for example, I can bring out a balloon that goes like this, and I can put a number here in of, say, 1, or I like to use letters for this actually. A, for example, and so that should say now A in it. A, click OK. I can put a call out balloon onto this part here. And that one can say, double click on that dot in a minute, and that one can say B, etc., etc. So I can reference those parts as I go along. I can put assembly notes on and things like that. Look on this view now, if I right click when it's selected, I can go show hide, show hidden lines, give it a second to pre-populate, and that'll show me the details inside the drawing of the hidden detail lines. Quite cool. So my general arrangement drawings, series of views. If you want to add to your general arrangement drawings, you can go insert view. You can click on there and you can pull in an isometric view if you want to. If you want your isometric drawing to be smaller, you can bring the scale down on your isometric drawing. So you can drop an isometric view up here if you want to. That gives you the scale of it as well. You can leave that in if you want to. Now let's start drawing some parts, right? So I don't have a great deal of space on this drawing for all the other pieces, so I might find that I have to have this on 2 separate A3s. Okay, let's try and draw part A out then. You'll get the idea once I've done one of the pieces. I'll leave you with that really. So go to Insert View and choose the thing that you want to draw. So you go down here to Hacksaw Model. Insert, go to Hacksaw Model, and let's pull out the pinch bar. All right, this one here. So I'm bringing in the pinch bar that we drew. There it is. Now, remember, your parent view can be whichever one you want. So I'm going to choose, I'm going to choose this as my parent view. Okay. So I'm going to drop that in, but I'm not going to use that as my, well, actually I will. I'll use that as my front elevation, right? So that's my front elevation. And I'm going to draw a side view now. So a side or an end elevation. So I'm going to look from this side, the right-hand side, and it's going to create me a drawing on the right-hand side. But look what I'm going to do with this view. Look, I'm going to create what's called a section view. So vertical, horizontal or angular. It's going to be a vertical one. And I'm going to pick where my section view is going to go. And I'm going to pull away. Okay, so look what it does. It creates me a sectional view through the object. Now, can you see those hatching lines are disrupted there? I want to change that a minute. So I'm going to go Edit Hatch Section. I'm going to click on the hatch I want to change. And look, I'm going to change it to the American standard. Same on that one. So I've got there a series of solid hatched lines, which is pretty good. Front elevation, sectional end elevation. That's pretty handy. Now, let's put some more detail in, right? Because this one here is lacking on some stuff. So I need to have a center line on each of these holes. 1, 2, like that. I've already got centers on there. They've already been put in. So what should we do? Should we put some hidden detail on this one? I think this view could do with hidden detail on. If I do that, see, I'll get a line across the base there that sort of clarifies what's going on at the bottom. Doesn't overcomplicate the view, but it does give us more information. So time to put some dimensions on now, right? So when we put dimensions on, we decide where are we going to dimension from. So if you've got a distance that's really critical on your design, such as, for example, distance between these two holes, which needs to be 31 millimeters, then you might want to put on a datum. So with a datum, what we do, so I'm going to bring a line over like that, and I'm going to draw a datum on this edge like this, datum A, because I want to make it clear to the person who's going to make this that the distance between these holes is really, really important. So I'm going to dimension from this one to this one, pull away, that's 31. I could, if I wanted to, put a tolerance on it. I'm going to put a deviation tolerance, so maximum and minimum values. Let's allow people to be 1/4 mil above or below. That's 1/2 mil tolerance altogether, though, so that's quite generous. And then we can put a geometrical tolerance on. So here, look, we could put a tolerance on saying that they have to be parallel. It's quite a handy one to do, I suppose. So this line needs to be parallel with, so we're going to say that's got to be parallel with, one second, close it off a minute. We'll click on that one. It's got to be parallel with the tolerance of, let's say, 0.1 degree to reference point A. Click OK on that. So that tells us that that center needs to be parallel to that center. Okay, let's put some more dimensions on, right? So when we dimension, we tend to want to dimension away from a datum. So we dimension everything with reference to line A. That's a normal way of doing it. But there are other rules that we've got to follow as well. So I'm going to go over those first, right? So first of all, let me put in an overall height for my object. I'm going to give myself a little bit more space for here. So I'm going to dimension from the bottom to the top, and by the way, that's 80 millimeters. I'm going to measure from the bottom to the hole, that's 71 millimeters. Dimension from there to there, which is 40 millimeters. And can you see what I've done there? I've done the biggest dimension outside and stacked all the others inside it. You don't want your dimension lines to be crossing, all right? So you can dimension on both sides if you want to, though. So this should be, should be 14 millimeters. There's something wrong here. All right, we'll have to change that. I'm not sure what's going on there. So I can put dimensions in for the other distances too. You can put different centers in if you want to. So you can put a dimension for a center on there. Now you can dimension the distance from there to the base. Okay, that should be 8 as well. So we've got some issues going on here. I'm going to have to go back to my model and make some changes, right? What else was I trying to show you? Right, so let's have a look at this one, for example, to highlight something. The distance between those two faces there, I think, is 1 millimeter. So if I click there and then I click on this one, look, what you'll notice is there's not enough distance between the gap there to draw the one. So if your dimension's smaller than 6 millimeters, BS AA, that's the rule for dimensioning. So it's fine to dimension it outside the line. Right, what else should I dimension? I can dimension the diameter of these holes, 6.5 and 6.5. I can dimension the radius of the top bit here, which is 6. So you've got to make sure you've got enough dimensions so that somebody else can make this object, right? So what else? So let me just move my parent view right up a bit, because I want to be able to put a dimension below this one. So if I go to dimension and I go from that edge to that edge, that dimensions that as being 12. Can you see I've got a problem with the one above it now? I need to make sure that that one there is not crossing my dimension line for my 12. Okay, I've got some problems there. I'm going to leave it like that. I would have to change that, and I'm going to do that in drawing properties where you go to dimensions, and it allows you to set up the gaps and stuff like that with your drawings, right? So 12's there, and I got to guess I've got to put the width dimension in. So pick a dimension. I'm going to put that above here, 12 millimeters. And just double check that you've got everything. I've got a few dimensions missing at the bottom here that I'd have to put in as well, but you get the idea. So you'd have to create the frame drawing in another piece of work, and you'd have to create the. So let me go in here, go insert, and go to Hacksaw model. So if I was bringing in this piece here, for example, I would be able to draw the turned section. Again, with the turned section, look, you might want to do a sectional view because you might want to show what's going on inside there. In that case, do what I did in the first set of drawings. So, you've got to make sure you put sufficient information on there that somebody else could manufacture it. It might go over 2 pages. You might have your general arrangement on a separate drawing and a parts drawing on a separate one. You've got to think about how it works, right? But try and keep the scale 1:1 if you can. It's okay in your isometric drawings, I guess. There you are, and that's it. So have a go and see how you get on. Right.